Hi, everyone. Before we get started with this week's material, I just want to take a moment to review some of the key points that we learned before that we'll be building on this week. So we talked before about the fundamental values in science and what makes science trustworthy and credible. And one of the important points we touched on is this idea of organized skepticism or organized distrust. And specifically, Don Campbell expressed this in this quote where he said, "The resulting dependability of reports comes from a social process rather than from dependence upon the honesty and competence of any single experimenter. Organized distrust produces trustworthy reports." And here he's referring to one of the four core values in science that the sociologist Robert Merton talked about that makes science kind of a special way of knowing or makes it different from other ways of knowing and makes it more credible. So the four Mertonian norms, and this is review from before, are the first one is universalism, which is the idea that it doesn't matter who's making a scientific claim, how famous they are, what their status is, what institution they're at. We should evaluate the validity of the claim on its own merits, not based on who's saying it and their status. The second Mertonian value is communality, which is the idea that science should be open and transparent and shared. There shouldn't be secrecy. We shouldn't ask people to just take my word for it. We should expect to be asked to show our work. The third value is disinterestedness, and this is somewhat controversial. Not everybody agrees that this is a core value in science, but it's the idea that scientists should be more motivated by finding the truth than by their own self-interest. And so it's okay to criticize each other because we're not necessarily out to bolster each other's kind of fame and reputation, but to find the truth. And so we shouldn't take it personally if somebody corrects us, because the truth is more important than our own self-interest. And then the fourth value is organized skepticism, or what Don Campbell called organized distrust. And this is the idea that we should expect people to be skeptical and critical of our claims, that that's a good thing, and we shouldn't treat anybody's claims as beyond skepticism. And this is different than universalism because it's not about who's saying it, but it's about the claim itself. So some things might be like very loaded politically or morally or religiously, but if it's a scientific claim, then it should be open to scrutiny just like any other claim, even if we really want it to be true or want it to not be true. So nothing is sacred, everything can be questioned, and we should seek to scrutinize everything. So if we want to live up to these norms, what are the ways that we can get there? These are all very lofty, abstract ideals. What does this mean concretely for scientists in terms of how they should operate? And we talked before about the importance of two mechanisms for making science credible and trustworthy, and those are transparency and quality control. I'm now going to switch to calling quality control critical appraisal because that's what some other people have called it, and I think it's a little bit closer to what I'm talking about. So we talked about how transparency is making things open and checkable, making it possible for other people to check our work, giving our critics ammunition, saying, if you want to find errors in my work, I'm going to make it as easy as possible for you. So that's the first step. But then the second step is also important, the critical appraisal, which is where people actually go in and use that transparency to look for errors or to try to verify the claim and see if it holds up. So transparency alone is not enough. It's necessary, but we need to actually use that transparency and make sure there are people going in and checking and looking for errors. So we talked a little bit about some reason to worry that this isn't always happening, that we're not always living up to these ideals. And one of the big signs of this is that there are so many positive results, significant results, discoveries in the literature, and relatively few published papers showing that things didn't work. And that can't be accurate. That can't be the whole story. So we already know just from what the literature looks like that it can't possibly be an unbiased, transparent picture of the research that people do. And we know that this is maybe especially bad in psychology, although it's true across the sciences. So this is a graph from a story by Ed Yong in the news, where he showed the proportion of findings in different scientific fields that are positive results, that claim to have discovered something, have found a significant effect. And you can see that psychology and psychiatry is at the bottom there, with over 90% of our published literature showing significant results, but there's plenty of other sciences that are well over 80%. So economics is up there, social sciences in general. So this is a widespread issue, and it also afflicts the medical sciences. So what's going on? So again, we talked about the different kinds of errors we can make in null hypothesis significance testing, the statistics we use when we use p-values, and about how with so many positive results out there, it's almost guaranteed that a lot of them are going to be false positives. So we talked about, we conduct our study and we know which row of this table we land in, whether we failed to reject the null, we got a non-significant result, in which case we're in the top row, or we got a significant result, we can reject the null, we're in the bottom row, and the bottom row is what typically gets published. And this includes both true positives and false positives. And so if almost all of the literature is positive results, is in that bottom row, then that means that probably what's happening is that researchers are doing their research, they're only publishing the ones that land in the bottom row, but they're probably not just wasting a bunch of studies that produce null results that land in the top row. There's probably ways that we're unintentionally pushing results down into the bottom row, that we should be landing in the top row, but we're engaging in research practices that push things down into significance. And so those include harking, or hypothesizing after the results are known, which is where you might not have hit the target you were aiming for, but whatever you do find, you find some significant results somewhere in your study and you write the story around that. You say that was your target. Another questionable research practice that produces a lot of positive results and therefore a lot of false positives is what's known as p-hacking, which is various research practices that help you get a significant result where really it should have been a non-significant result. So there's many, many different ways to p-hack. Here's just a few. There's a lot of literature out there on p-hacking if you want to learn more about what p-hacking looks like. But basically it means giving yourself a lot of chances, analyzing your data a lot of different ways. And then there's a third questionable research practice, which I mentioned in passing, file drawing, which is where you land in that top row. You don't p-hack, you don't push it down to the bottom row. You just sit with a null result and you don't publish it. So it's called file drawing because it means we put it in a file drawer instead of telling the world about it. So what these questionable research practices have in common is that they kind of beautify our results. They make it so that the world sees only a very skewed and positive version of our results instead of an accurate representation. So if this is what our actual research results would look like, unfiltered, transparent, we put them through things like harking, p-hacking, file drawing, and we end up with a much prettier picture. Now, when I talk about this, I sometimes slip into talking about it as if it's intentional, and it can be sometimes, but probably most of the time it's not intentional. We're not aware that we're doing it, or we're not aware of the consequences of doing it. This was captured really well in a quote by one of the researchers who coined the term p-hacking, Joe Simmons. And he was quoted in a news article that was published about a year ago by Christia Schwanden called "We're All P-Hacking Now." And in that article, she's talking about Joe Simmons, one of the authors of the idea of p-hacking, the term p-hacking. And she says, he and his colleagues have been very explicit that p-hacking isn't necessarily a nefarious endeavor, but rather a human one, and one that they themselves had been guilty of. At its core, p-hacking is really about confirmation bias, the human tendency to seek and preferentially find evidence that confirms what we'd like to believe, while turning a blind eye to things that might contradict our preferred truths. Then she goes on to write, the hacking part makes it sound like some sort of immoral behavior, and that's not helpful, Simmons says. People in power don't understand the inevitability of p-hacking and the absence of safeguards against it. They think p-hacking is something that evil people do, and since we're not evil, we don't have to worry about it. But Simmons says that p-hacking is a human default. It's something that every single person will do, that I continue to do when I don't pre-register my studies. Without safeguards in place, he notes, it's almost impossible to avoid. So what we're going to be talking about this week is those safeguards. So since we became more aware of this idea of p-hacking, it wasn't completely new, but we became more aware of it around 2011, almost 10 years ago. And we've done a lot of things, maybe some people argue too many, some people argue not enough things, to try to deal with it. So what we're going to talk about this week is mechanisms to help prevent p-hacking and help safeguard against just misleading ourselves, fooling ourselves, which, because we're human, we're very susceptible to. So what we'll be talking about this week is how can we live up to our ideals, to the Mertonian norms, for example, and our core values in science. And we could summarize these 4 values to me as prioritizing and committing ourselves to self-correction. As we talked about earlier, these 4 values are all really fundamental to a self-correcting science. If we want to detect and correct our errors, we need to be able to challenge anyone regardless of their status. That's universalism. We need to be able to find those errors. That means we need things to be open and transparent. That's communality. And then we need to be allowed to challenge people even if that goes against their self-interest. That means we need to value truth above self-interest. That's disinterestedness. And we need it to be the case that it's always okay to be skeptical and ask for verification, regardless of what the finding is and how much we want to believe it. And that's organized skepticism. So I'll be talking about these attempts to improve and address these problems under the umbrella of transparency and critical appraisal, the same 2 kind of pillars of credibility that we talked about before. And specifically, I'm going to talk about what I've called the credibility revolution in psychology, which is the attempt to try to bring more attention to these problems and try to develop solutions for them. So that's what we'll be talking about today.